Hello guys, welcome to another video. This is finishing off like the lesson 20 set of notes that I have. Remember we were doing things of this form, like f of x equals some squared thing where you have adding or subtracting or multiplying of numbers. We're going to come up with the last part involving this a of what if that a, that coefficient, is a different number from 1. We already covered if the number is negative, it's like a negative flip. But what happens in the rest of these situations? So that's what we're going to cover today here. So what if there's a coefficient in the front? We have some f of x is equal to a x minus h squared plus k. This is like the form we are looking at, and we call this is called vertex form. Why? Because I can see what the vertex is already. The vertex is h comma k. Like in this prior video, I saw this. My vertex is -1 comma -2. I draw my vertex. I can draw my graph like that. So vertex form is important for us. We like vertex form. Well, how do we do this? By looking at a graphing calculator. So let me share what this is going to look like. First, screens. Um, It should be in the right spot. Let me click share one more time. Yeah. Okay. So we have something like this. Let's see what happens when I do y equals, and instead I have some sort of multiplied number in the front here. Let's do 2x squared. Well, it still looks like a parabola. Nothing's changing. And let's even here, let me actually do like something of a full form, right? So let's do um x minus 2 squared, x plus 3, right? So this is like the standard form here. Let's do the same graph, but let's put like a 2 to it or something like that, or a 3 to it, or a 4 to it. Or actually, let's do the slider thing like I did last time. So look what happens when I'm at 1. Here, let me make this between 0 and 10 here. When I at a equals 1, it's like I have an imaginary 1 here, right? Or if I move this slider, what happens to this new graph? My graph is black now, right? What is happening as I get a higher and higher value for my a, it's like my graph just ends up vertically like shrinking, right? It's like or actually it's more like a vertical stretch. I'm vertically stretching. It's like I take the two endpoints of my graph and I pull it up so there's less being taught here. So as I get higher and higher, it gets long, like more and more skinny. And as my a gets lower and lower, it fattens up, and then I reach the point of 1 here, right? 1 is right where we at. And then as I get below 1, look what happens. My black graph gets fatter and fatter and fatter until when I get all the way to 0, it's going to look like flat. But even if I like go a little bit of an A here, that's like 1/100th, right? When I have a small a, it's fat. But once my A gets bigger than 1, like this, I start getting skinnier than the parent graph. That is what we want to know here. We have fatter parabolas and skinnier parabolas. Now, these are called vertical stretches and vertical shrinks, like that. So we're gonna draw that in our notes here. Let's go to notes. So I'm hoping this could be a smaller video in comparison, but we'll see. We'll see. Sometimes graphing takes a bit, right? Okay, so what do we have here? We have a number in the front. If a is bigger than 1, then the graph vertically stretches. So let's look at an example here. So let's say I have my parent graph. like this. A vertically stretched graph with a bigger than 1 coefficient is going to look maybe something like this, right? When A is bigger than 1, I have a graph that has a skinnier look to it, right? Well, what about the other way? If A is between 0 and 1, then the graph vertically shrinks. We call it vertical stretches and shrinks, but really I'm more worried about, here, let me see if I can just copy and paste this stuff. Copy, paste. I am more worried about how you know it's supposed to look. I don't really care if you like know the actual name, but a vertical shrink looks something more like that. Whenever you have a fraction for your a fraction less than 1, you have a graph that looks more like that. And that's pretty much all you need to know to graph any parabola, right? Parabolas always look something like this. They have a certain width, they have a certain skinniness, or they have a flip, or they're direct and at a starting point at a certain spot there. If you have your vertex and you know what your coefficient number is, you know what it's supposed to look like. So let's try that. For f of x, I'm not going to plot points here. I'm just going to go straight into graphing, straight into sketching here, if it'll let me. Well, let's sketch. What's the information we have here? Sketch. We have a vertex, right? Our vertex is HK in this form here. So my vertex is 3 and -2. Remember, it's positive 3 for my vertex because there's already a negative in this formula here. And it's -2 because there isn't a negative there. So you got to keep that negative with it. So it's a little tough to keep track of, but still work with it. And we have A equals 2, which is positive. So it is a positive number, which means it's going to be happy. I know where the vertex is going to start, and I know it's going to be skinnier because graphs vertically stretches when you have a larger A value. So let's put all that together. We have a graph that starts 1, 2, 3, 1, 2. This is where my vertex is, right? 3, -2. I know it's a positive number, so it's going to go up. And because my A is 2, I'm going to make it a little skinnier. Or that's a lot skinnier, but let's go a little skinnier like that. You know, I'll make it more exaggerated. Why not? Like that. And we're done. What about something like this? Let's sketch it. We have a vertex of -1 and 2 for this problem. This is x plus 1 squared. Because we have a negative in here, we have to change the sign of that h value, of that number, so that there's a negative in there. And then my k is the same thing. And my a is equal to -1/3. So it's a fraction smaller than 1. It's in this situation. And it's also negative. So I know it's going to be upside down. So we draw our graph. My vertex goes over -1 up to like that. That is my vertex. It is unhappy graph, but it's also fatter. So it's going to look maybe something like that in that exaggerated way, right? It's not perfect. It's not a perfect graph, but it's kind of like good enough here. Maybe look a little more centered. There we go. Doesn't have to be perfect. Okay, so you know how to sketch any parabola now with this video finished. Here's the thing. Things don't always look like this. If we have it of this form, we got it right away. And we got it right away, and that's just nice. We don't always have it of this form. We have to use some prior, I'll say, some prior tricks or processes to figure out things of that here. And I wrote down a little bit of a list for how we're going to do that. It's going to involve completing the square. So if you felt comfortable with completing the square, you're going to be really happy here. in order to complete the square, you have to make sure you don't mess up the problem or change what the function actually is. So we're going to have to like add and subtract the same value, but we'll just show a couple examples of this as well here. If it says sketch a graph of this, I don't know how to sketch a graph of this form. I only know how to sketch things of this form. So we got to change it to that form here. We got to change it to be something squared. So how does this process go? Well, first, if you have an a in the front, you want to factor out a on the first two terms. We don't have that, so that's fine. But we'll still go through this process nonetheless. Then complete the square on the first two terms. So what I'm going to do, right, if you remember the complete the square method, I'm going to leave some space for completing the square on the first two terms. And if you remember, what's to complete the square thing? We have to add b over 2 squared. That's the number we add in these problems. So what is b over 2 squared in this problem? Well, b is your middle coefficient. So this is 8 over 2 squared, 4 squared, or 16. So I'm going to add 16 and then subtract 16. That is what this is saying. I can't, if I add 16, you can't just add numbers willy-nilly, right? That changes the function. We want to make sure we're doing nothing different. We're just kind of rearranging and massaging these numbers so that we can hopefully factor this into something that's cleaner for us to graph. In order to do that, if I add 16 and then subtract 16 right away, if I add 1, subtract 1, I'm back to where I am. If I add 16, subtract 16, I'm also back to where I am. So this is not um, changing the problem here, but it's going to be nice for factoring these first three terms. So that is what I'm going to do. I'm going to factor these first three terms, and I have what? 16 and 8. What factors to be, or what multiplies to be 16 and adds to be 8? That is 4 and 4. So we have f of x is equal to x plus 4 squared. And then the outside is negative 16 plus 10. This is minus 6 here. Well, what do you know? This is something that I can graph now because this is of the vertex form that we like here. This small little trick gave us that advantage now to where I don't have to graph by plotting. I can just do my little sketch, right? This is the vertex is -4, -6. So I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. The number in the front, there is no number in front, so we can just imagine it being like a 1, which means it's going to be a happy graph, and we're not going to stretch or shrink at all. We're just going to draw it. Like, there you go. That's the sketch of the graph. Not bad. Okay, we'll do one more. This one's also like a little harder, I would say, because there's a number in the front. So again, remember when we were doing completing the square, we were really just focused on these two terms. So that's what we're going to stay focused on. When you have a number in the front, you can't do the complete the square method yet. So we're going to push that number to the side and then factor those two front terms or complete the square on the two first terms. So first step, we're going to factor a on the first two terms. So this is going to be 2, it's factored, and I have x squared minus 6x. I'm going to leave some space, plus 14. Oh, I'll even do that. This is just a step 1, right? Why not? Why not? Why not? Why not? F of x equals. Now I want to complete the square on the first two terms. I have x squared minus 6x. Well, what is to complete the square method? Well, my b I'm going to have here is -6. So b over 2 squared equals -6 over 2 squared, which is -3 squared, or 9. So that's the thing I'm going to add here. I want to add 9 and then subtract 9 right away. And in my notes, I have something a little different. I'm going to do something I'm going to like put this all in one step here. I have an adding of 9 in the parentheses, and I'm just going to write something here. I'm going to write minus 18 outside the parentheses. Now, why did I do that? Why did I do a minus 18 outside the parentheses instead? Well, if you look, this is 2 times this stuff, and I'm going to want to have like this be factoring eventually. So I add 9 inside the parentheses, but really I didn't add 9 to the function. I added 2 times 9. If I distributed this back in, I'm going to have 18 here. So because I added 18 into the function, I need to subtract 18 to balance it out. Just like when I added 16, I need to subtract 16 here. When I add 18, I need to subtract 18 here. That's why. So I did that all in one step. F of x is equal to, well, this is 2, and hopefully this thing factors now. I'm going to do this to the side. -6 and 9. What adds to become -6 and multiplies become 9? This is x minus 3. So x minus 3 squared, and then -18 plus 14 minus 4. Like that. Nice. So hopefully this graphing shouldn't be too bad now. I'm kind of jumping the gun here. We have a is equal to 2, and we have the vertex is equal to 3 comma -4. So I'm going to go over 1, 2, 3, down 1, 2, 3, 4. That's my vertex. A is positive, so it's happy, and it's 2, so it's a little skinnier. I'm going to draw a skinnier graph, skinnier parabola, like that. Now on Alex, it might tell you that plot at least 2 points or plot your vertex and like another point or something like that. Follow the things for Alex, but what I'm wanting you to know is that any quadratic now, we should be able to graph. First step, get it in this form. Next step, do the sketch stuff. All right. And that is it for this video. I think that's a little bit shorter than the last one, which is good. Thank you guys for watching. It's always fun talking to y'all.